So I really feel like I want to at least say this. So they're telling me that the magnitude of A times the magnitude of B times, I got better write it correctly, sine of theta. And theta is the angle between the vectors, so this seems like it's making progress. It has to be greater than negative the magnitude of A, the magnitude of B, cosine of theta, and that has to be greater than 0. Well, I can divide by these magnitudes. Ooh, and so I need sine of theta to be greater than negative cosine of theta. I think sometimes when there's a negative in a formula, it bothers people. That does not mean this is negative. In fact, it's positive. What it means is that cosine is negative. Okay, at that moment, you've made enough progress that you could even just try the examples. We probably could also solve. Now, one comment is the fact that negative cosine is greater than 0. That actually means cosine must be negative. So because I know my unit circle, cosine's the x-coordinate, so I already know that we're talking about something over here, because that's when the x-coordinate is negative. So something between 90 degrees and 270 degrees. So I think that rules out a few things, like it can't be this, because otherwise you'd have cosine is negative. It can't be that. So then we're down to a couple possibilities. At that point, you could even try them. You want to know which ones make sine bigger. So for example, you could plug in, even just plug in 90 degrees. If you plug in 90 degrees, you get 1 is greater than negative, 0 is greater than 0. Oh, it says between, so you're not supposed to plug in 90, but that gives me some information. You could plug in 135. You could plug in what would be a nice value in between 150 and C. So what else can I say here? Yeah, I was just trying to see if I could avoid, like I said, if you have a calculator, you could be done immediately, because you could just test 120 degrees, see if this is true, see if this is bigger than this, then you'd be done. So we are at a point where as a student you could answer it. If you're someone that want to know where the answer came from and you didn't have it in front of you, you could try to keep solving, meaning try to conclude what you can about this. So if you divide everything by cosine, you're going to get sine over cosine, which is tangent. So I need to have tangent greater than negative 1. So that boils it down to one trig function. And I know quite a bit about the tangent function, that it looks like this and this and this. So I want to know when it's bigger than negative 1, wherever negative 1 is. So we could go to our unit circle. Sorry, I'm suddenly yawning. I've been staying up too late. I apologize. All right, let's move on. I think we've hit the idea enough. You could find when cosine is negative 1, and that would be at, let's see, 45 plus 90, 135 degrees. Okay, so it's before that. But I think even I would have tried some examples at that point. Okay, on to the next one. So there's part A. Part B. But you can see I did the formulas, and then I'm doing some examples to finish. Okay. One thing about these is they often involve the following idea. So if you're still kind of struggling with projections, you always have a ground vector, the thing you're projecting onto, and then the vector you're projecting down. And what that means, you're going straight down here. Now when you form a projection vector, it points the same way as A. So this points the same way as the A vector points. That has to be true. Because of that, you can say something here. So it's a interesting little quirk of these problems, but if you've looked at a few finals, you've seen it, which is that you can use any vector on the ground. And we have one instructor on our department that likes to ask things like this. So can I give a different vector that's on the ground, meaning a different vector that's on this line? Because if I change that vector, I'm still going to get the same projection. What I'm saying is you could change this vector to a vector that's 10 times as long, and you're still going to get the same projection. You can make it 3 times as long, and you're still going to get the same projection. So do we have access to a vector that points that way? We do. So this is a quirky little thing, which is you could always take this vector and put it here for A, and it's not going to change the answer. So that's the clever little thing. So in this formula where it looks like I don't really know anything, I actually can put A. I can replace A with 1, -1, 1. That's the trick of the problem. Okay, so if I do that, what happens? So I'm going to replace A with, so I don't know what B is. Let's just call it B1, B2, B3. I'm dotting it with what I'm replacing A with this. I'm dividing by A dot A, and I got this from the projection formula. And I'm multiplying that times A, and it needs to come out to be equal to A. So the truth is that means that all of this has to be 1, is what we can conclude. And let's summarize that up here. So we can say that B1 minus B2 plus B3 all over 1 plus 1 plus 1, which is 3, has to be 1 for those two sides to be the same. And so that means that B1 minus B2 plus B3 has to be 3. So there are many correct answers, but they weren't asking you to solve. They were asking you to check these possibilities. So does it work with a 2 and a -2? No, because that's going to give me 6. So I'm just going to calculate for each one of these. What is B1 minus B2 plus B3? And see if I get 3. This one gives me 6, so no dice. This one gives me -1, -1, -1, which is -3. Close, but no cigar. I'm going to put this in. This is going to be 2 minus 2 plus 2. Nope. And then it's going to be 2 minus 3 plus 4. Aha, it's the only one that works. So both of those were an unusual collection, but I hope I'm at least giving you the thought process. That one I feel like is the tricky one. You know, if a student hadn't prepared and looked through enough finals, they wouldn't have been ready for that. So the trick was to replace this here. All right, let's keep going. So I feel like those two were challenged. It's a tough place to start, but I gave you some ideas here. And if you were stuck like that, just move on to the next part. I know you're going to come back and do some examples. Okay, so what about this one? Find the intersection of the hyperboloid in the xy plane. Okay, that sounds a little tamer because that's saying z equals 0. And so you have x squared plus y squared minus 0 equals 1. So you have x squared plus y squared equals 1. It's a circle. And in fact, it's because of that that we call that the hyperboloid of one sheet. So if I was going to label these, this is a good example of, in my mind, that was easy and fast to do. The first two were less so. don't let the first two affect how you feel about the whole page. So about these multiple choice questions, just treat each part independent. And try to not let that affect you. Sometimes it affects students too strongly. The surface has a local maximum of what? So this one I also have a clear, direct strategy. I know that I could do this a longer way, but I may be able to get away with being a little shorter, but I'm just going to write the first step and do it correctly. So I'm going to do the partial with respect to x is this, and the partial with respect to y is this. They're not actually asking me to solve it. So one thing, because they gave me these numbers, I can plug them in right away. Like, does 1, 1 make both of these 0? It does. Now that does not mean it's a maximum, but it does mean it's something that's a critical point. Does 1, -1 make it 0? Yes. Does -1? Oh, all of these do. Okay, so they all are critical points. So they save me having to actually solve it. Now I need the mixed partials. F of xx. Sorry, I need the second partials. Is 6x. F of y is 6y. F of xy is 0. F of yx is 0. Okay, so the d is actually pretty nice. It's going to be 6 times whatever the x is, 6 times whatever the y is, minus 0 squared. Okay, so one by one, we're just going to try. So if you plug in a 1, 1, you get that this is 6, concave up. This is 6, concave up. So at this point, you get d is 36, and it's concave up. So that means it's a local minimum. So that's not it, because the question's asking for maximum. Okay, so then we plug in a 1 and a -1, but that makes it -36, which makes it a saddle point. So this was a min, this was a saddle, this is also a saddle because you're going to get a negative and a positive, so -36. It's got to be that one. You put in a -1, a -1, you get that you're going to get d is positive 36. And then the mixed partials are negative. I'm not the mixed partials. The second partials are negative. It's concave down in all directions. That's a max. So I don't know. I feel like that's medium difficulty at most. It's definitely something we can do. Okay, then the next one. A lamina occupies the disk, and the density is this. The center of mass is what? Okay, so this is a little bit of thinking. This is mostly about this symmetry stuff. So this is good for us to talk about because it shows you how you could save time on a center of mass question. So let's say you have this circle, radius 1. That's what they're saying. It's completely symmetric. Now that does not mean that the center of mass is 0, 0. It depends on the density. And this is just generally true about double integrals, is that you also have to consider the surface. Double integrals have a surface or a function and a region on the ground. And if you want to use symmetry, both have to be symmetric. So when I go to look at the density, is the density symmetric? And what I mean by that is if I plug in values above and below, do I get the same thing? For example, if I plug in 0, 1, which would be like up here, and 0, -1, is it the same? So if I cut out a little piece, do the different sides weigh the same? And this was y squared. And the answer is actually yes here. It's symmetric with respect to y. You can do it without even plugging a number in. What I'm asking is, are these two things the same? And they are because of the square. So there is symmetry this way. So the region is symmetric this way, and the density is symmetric. So the center of mass has to be on the x-axis. What about if you change your x this way? What can we say? So if you plug in -1 here and +1 here, are we going to get the same thing? Or in other words, when you plug in -1, 0 and 1, 0, are those the same? Well, no, 'cause it's going to be -1 plus 0 plus 2, which is 1. It's like the density over here. And the density on the other side is 1 plus 0 plus 2, which is 3. So it's heavier on this side, which is going to mean the center of mass is a little bit that way. And so it's none of these other ones on the x-axis. All right, hope that answers your question.